Mathematical induction example. Example 1. For all n is greater than or equal to 1, prove that 1 plus 2 plus 3 plus 4 plus dash 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 plus n is equal to n times n plus 1 over 2. In order to solve this question, what I'm going to do, I'm going to consider that this statement is Pn. So I will write Pn says that 1 plus 2 plus 3 plus 4 plus dash 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 plus n is equal to n times n plus 1 over 2. So what I'm going to do, I'm going to use the principle of mathematical induction to solve this question. So I will take, for n is equal to 1, I'm going to substitute over here n equals to 1. So I will write P1 is equal to 1, which is the first term, and then I'm going to substitute the value of n equals to 1 in this expression. So I will write 1 times 1 plus 1 over 2. So I will write 1 times 2 over 2, and 1 times 2 is 2, so 2 over 2 is 1, and basically this one is our first term of the expression. So basically this statement is true for n equals to 1. Now let's consider n equals to k. So for n equals to k, we will write pk is equal to 1 plus 2 plus 3 plus 4 plus dash 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 plus k is equal to k times k plus 1 over 2. So basically what we are doing, we are substituting the value of n equals to k in this expression, and that's how I'm getting this expression. And as you can see, this expression is same as this expression, the actual expression. So we can say that pk is true. Now let's consider n equals to k plus 1, and if we have n equals to k plus 1, what we will do, we will substitute the value of n equals to k plus 1 on this expression, and if we do that, we will write pk plus 1 is equal to 1 plus 2 plus 3 plus 4 all the way to k plus k plus 1, because my nth term is now k plus 1. As you can see, the expression from 1 to all the way to k, basically this part of the expression is my pk, which is basically k times k plus 1 over 2. And this term k plus 1 is extra term, which is over here. Now I'm going to further simplify, and if I do that, I can take k plus 1 common. So my k plus 1 is common, and inside the bracket I have k over 2 plus 1. Because as you can see, k plus 1 is common for both these two expressions. Now if I further simplify, I will write k plus 1, and then the term inside the bracket will be k plus 2 over 2. If I rewrite this expression, I will write k plus 1 times k plus 2 over 2. Which simply means that if I substitute the value of k plus 1 in this expression, then I will substitute this n as k plus 1, and then this n will become k plus 1, which is basically k plus 2. So the right term of this first expression will exactly look like this expression. So I can write k plus 1 times k plus 1 over 2, which is basically exactly the same as the right hand term of the first expression. So I can say that pk plus 1 is true if pk is true, and basically you can see pk is true. So we can say that the statement Pn is true for all natural numbers.